Consider five letters of the English alphabet: P, Q, R, S, T. And let's say we want to find the number of ways in which these letters can arrange amongst themselves such that Q always comes before S. So Q always comes before S. So this is one possibility, right? Because Q is coming before S in this arrangement, right? We could have other possibilities as well, such as the following. You could have Q here, then you could have P, S, T, R, right? So here also Q comes before S. So on and so forth, right? You could have more such combinations where Q comes before S. So how do we go about finding the total number of possibilities where such a case happens? So now let's imagine a situation where we do not have any restriction and we want to arrange these five letters. In how many ways can we do that? We can do that in 5 factorial ways, right? Now, all these letters are distinct. That's why we can do it in 5 factorial ways. Now, uh, imagine if you talk only about Q and S, in how many ways can these two letters arrange amongst themselves? 2 factorial, right? Because two distinct letters, right? Now, out of these 2 factorial ways, there is only one way in which Q comes before S, right? There is only one way where Q comes before S, right? Out of these 2 factorial ways. So the desired number of ways in which these 5 letters can be arranged such that Q is before S is going to be 5 factorial upon 2 factorial. The intuitive way of looking at this is, if you basically laid out all the possible permutations or arrangements of these 5 letters, there will be exactly half ways in which Q would come before S, or and there will be exactly half ways in which Q will come after S, right? That's why 5 factorial upon 2 factorial, right? Now, let's say there are 8 people and they need to be arranged in a row, right? At 8 different slots. Now, in how many ways can we arrange those 8 people such that A always comes before B, and B always comes before C, and C always comes before D, right? So A, B, C, D are name of the people, and there are other 4 people also. So there are 8 people. We have to arrange 8 people so let's say if I name the slots, so 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 slots. So we have to arrange 8 people in 8 slots such that A always precedes B, B always precedes C, and C always precedes T, right? It's not necessary that A comes immediately before B, or B comes immediately before C, or C comes immediately before D. But this order is important. A should come before B, B should come before C, and C should come before D. In how many ways can you do that? Okay, now if you look at this problem carefully, this is a natural extension of the previous problem that we worked on, right? Now, if there were no restrictions, right? If there were no restrictions for people sitting in this 8 slots, in how many ways could we seat those people? 8 factorial ways, right? So these people could be seated in 8 slots in 8 factorial ways. Now, in how many ways can these 4 people, A, B, C, and D, arrange amongst themselves? So these 4 people, A, B, C, and D, can arrange amongst themselves in 4 factorial ways, right? 4 factorial ways. And out of these 4 factorial ways, in how many, what are the possibilities? In how many ways can A come before B? Can B come before C? Can C come before D, right? So there is only one such case, right? So if you lay out the arrangements of A, B, C, D, right, there is only one possible case where A comes before B, B comes before C, and C comes before D. So the desired result will be 8 factorial upon 4 factorial. So the number of ways in which these 4 people can be, these 8 people can be arranged in 8 slots such that A comes before B, B comes before C, and C comes before D is 8 factorial by 4 factorial. Okay, now let's look at an alternative method to look at this problem, right? So let's say um, out of, so let's write down the slots, mention the slots. So this is 1, 2, 3, 4, 5, 6, 7, and 8, right? Now let's do this. Let's try to uh, find out and fix the slots for A, B, C, and D and make them seat first, right? So if I had to select four slots out of these eight slots for A, B, C, D, in how many ways can I do that? I have to choose four slots out of the eight slots. So I can do that in eight C four ways, right? So now I have selected four slots out of these eight slots where I can place A, B, C, and D. Okay, the next question is in how many ways can I now seat A, B, C, and D in those four slots? Remember, as you identify, let's say that, for example, let's say that you identified 2, 4, 5, and 7 as those four slots, right? Let's say if these four slots were identified now for A, B, C, D, in how many ways can A come before B, B come before C, and C come before D? Only one way, right? That's the only one way. So now, if you had to seat A, B, C, D, you could do that in only one way. So you multiply this with 1. Now you also need to seat the remaining 4 people in the remaining slots. That can be done in 4 factorials, right? So you multiply this with 4 factorial. And this is an AND operation, right? Because you need to do all these things. You first need to select those 4 slots for A, B, C, D. Then you arrange A, B, C, D in one way because that is the sequence we are looking at. And then you arrange the remaining 4 people, right? Now, if you actually go ahead and calculate this figure, 8C4 into 4 factorial will exactly be the same as this figure, right? Thank you.